Hello everyone, this is Satyanarayanan studying Master of Data Science at Deakin University. In this video, I'm going to show you how my version of the famous Flappy Bird game is built. Before showing the details, let me show you how it runs. When we start the game, we have this home page which displays the player's current score and the overall high score and some information to start the game and to quit the game and a note on what we should be doing while playing the game. So after starting the game, pressing the space key will make the bird fly. Okay. So I'm pressing space key now. So it is making the bird move upwards. The goal is to pass through these walls when the bird hits either of the wall, either up the upper wall or the lower wall, the game actually exits. Let me show you that. Yeah, it exits and it comes to this home page. Right now we have crossed four walls, so the current score is four, and the overall high score remains the same. If you see, whenever the bird crosses the wall exactly at the center, the score will get updated. The game also quits when the bird falls down. So this is how the game actually works. Now let me show you the overall UML diagram of how this game is designed. We have the main program here, and we have, other than main program, we have five different classes here. The home page class, which is used to create the home page of the game. This is the home page, by the way. And the Flappy Bird class. This is the coordinating class, which is used to coordinate all the other three classes and makes the game run. And we have the bird class, which is responsible for this bird object. And we have the wall class, which is used to create the wall here, both the upper and lower wall. And we have the scorecard class, which is used to create the score, update the score, and then display the score. It is also used to find out the high score of the game. Now, let me show you the actual coding part of how this game is created. First, let me start with the main program and I'll explain how homepage works, and then I'll explain all these three classes, bird class, wall class, and scorecard class, and finally I'll explain how Flappy Bird works, because this is the coordinating class which coordinates these three classes, and only with these three classes this class will be working. Okay, in the main program, first we are creating a window for the game. uh, this is the line. For that we are naming the variable as canvas, and the width and height of this is 1200 pixel and 700 pixel. And next we are creating a scorecard object called game score, and we are declaring two variables for the game itself, Flappy Bird, and for creating the home page. So The main logic behind this program.cs file is we are having one do while loop, and inside that do while loop, we are having two different do while loops. So what it does is inside this first do while loop, the home variable that we declared already is used for creating a home page object, and this game variable is used for creating the Flappy Bird, the coordinating class that we talked about earlier, that object. And inside the first do while loop, this home page, home dot handle input. So this home page is created and displayed. So this that we are seeing here is coming from this part of code, and it will keep on running until the player either enters the game or quits the game. So that is the logic behind this. And if the player wishes to quit the game, this do while loop stops, and then it comes out of the loop, and then the program ends. But if the player wishes to play the game, it goes to the second do while loop. So else if home dot play game. So if the player wishes to play the game, it goes to this do while loop. This do while loop in turn calls handle input from the game class, I mean game object. So the Flappy Bird class, and it is run until the canvas is closed, or the play game is set to false. That is, if the play, this is actually a boolean variable here. If this is true, the control comes here, and if by any chance if this is set false, the loop immediately quits, and the control again goes to this top. A new home page is created, and a new game object is created. So this is all about program.cs. Now let me show you how my home page object is, I mean home page class is created, and how it works. First, we are declaring few variables for BG image, BG bitmap for background image, and bird bitmap for the bird image, and game window for getting the window here, and this is the play game and quit game Boolean variables that I talked about earlier. Initially, when the game starts, the play game, this one is set to false. So in the when the home object is created, this play game variable is set to false initially, and quit game is also set to false. And we have the scorecard object, scorecard, I mean play score to create a scorecard object, and high score to store high score, and current score to store current score. So basically, whatever we are seeing here is stored in these variables. Current score is this your score, and high score is this one high score. This is the initializer for this class. It gets in the game window that we created in the program.cs, and scorecard from the scorecard object that we created in the program.cs as well. So we are just setting the variables to its respective values here. BG bitmap is equal to new bitmap. This one It's just like loading the file from the images folder here, bg and bird. So it's just loading the file from images folder here, and this this one is loading the bird.png from the images folder. And for setting the high score and current score, we are first creating the um, scorecard object here, and we are saving it to player score, and then we are uh, calling get high score and send score methods from this scorecard class. After initializing the class, the next major thing is we are handling the inputs, and then we are drawing the elements. So for handling inputs, as we are seeing here, enter key is used to go into the game, and escape key is used to quit the game. So by clicking enter key, we are setting the play game variable to true, and then by pressing escape key, we are setting the quit game variable to true. So if the play game variable is true, this in turn is checked here, and the control straight away goes from this loop to this loop, else if, and inside this it goes to this loop, game.handle input. And finally, we are after checking the inputs, we are drawing the elements. So we are first clearing the window, drawing the background, and then drawing each of the elements separately. And then we are refreshing the screen. So this is about the home page class. Now that we have created the home page class, let me show you how the bird class is created. For creating the bird class, similar to the home page, we are declaring the variables first. X and Y is used to set the X and Y position of the bird. So the exact position of the bird. And this quit variable is actually used to quit the game. That is, this quit variable is responsible for um, quitting the actual game. That is, from this screen, it just brings to this home page screen. Only the quit variable in home page, this quit game, this variable is the variable is which is used to quit the game. And we have the width and height variables for setting the bird's width and height, and we have gap is equal to, we have two constants, gap is equal to 10 and offset is equal to 100. So this gap is used to check check in the if the bird is on the screen actually. And this offset 100 is used to bring the bird towards a little bit left. I didn't want the bird to be exactly at the center, so with this offset, I'm just bringing the bird a little bit left. And we have the home page, home variable declared for home page object, and file path for file path as string, and score for scorecard object. So this file path is the file path of this high score text file. So whenever the home page is displayed, it displays high score. The high score that we are seeing there is from any one of the score is from the maximum score from this file, this text file. So this file path string variable is used to store the path for that file. And we have the initializer class here for the bird class. We are loading the bird PNG to bird bitmap variable, and we are setting the X and Y variables here. Um, X is nothing but the width of the game window minus the width of the bird divided by 2 minus offset. So it's nothing but width of the game window minus width of the bird divided by 2 gives the center of the X center of the window, and offset minus offset gives you a little bit moves the bird a little bit left. And similarly, y game window dot height minus height divided by 2. And we are drawing the bird with map on the screen, and we are setting the quit initially to false. So this is about initializer and bird class. The next method that we're having here in the bird class is the draw method. The draw method is used to draw the bird bitmap image onto the screen and stay on window. This is used to check the position of the bird. If the y position of the bird is lesser than gap, it sets the y position to gap. That is, if the bird tries to go above the screen, it will not allow the bird to go above, but it just sets the y position to the gap value, that is 10. So the bird always stays on the screen. And if the y position is greater than limit dot height minus bitmap not height minus gap, that is, if the bird tries to if the bird goes below this screen, that is below this line, the game actually it calls the game over method from this class, and the game actually quits back to the home page. So this is about the stay on window method, and we have handle input method here in the bird class. So pressing space bar will make the bird move upward. So we have a move method here which actually makes the bird move. So we have definitions here for just making that x plus is equal to x distance, y plus is equal to y distance. So we are um, setting the y to be minus y every time the space bar is pressed. So every time the space key is pressed, the actual y value of the bird is reduced by 5 units, and it appears like the bird is moving upward. And if the space key is not pressed, the y variable is added 5 units. So Whenever the space key is not pressed, the bird appears to move downward. So this is the logic behind it. And if the escape key is pressed, it again calls the game over method and it goes back to this homepage screen. We saw about the move method, and next we have this collide with method. This method is actually checking the collision of the bird with the wall. So if the bird collides with any of this method basically checks if the bird is colliding with any of the walls here. So that is achieved by an if else statement. If the bird dot we are basically using rectangle collision for this. Um, if the bird's x and y position collides with the upper wall, or if the bird's x and y position collides with the lower wall, it this function returns true, or else it returns false. And finally, we have the game over function. This game over function sets the play game variable that we saw earlier to false, and it updates the string. It updates the notepad file, text file that we saw earlier, this high score text file of the current score. So every time when the game over function is called, it writes this text file, the current score of the player. And this is all about the bird class. Next, we have the wall class. Similar to bird class, we are declaring few variables. X. We don't want two different x variables for this wall class because x is always going to be same. It is always parallel, right? So x is always going to be same. We just want the y variables to be different. So we are just having one x here, x here, and then we are having two y's here. Dy is for the down wall and uy is for the upper wall. And we are declaring upper wall height, lower wall height, wall width, and we are declaring a variable for the color of the wall, and then velocity, and these are the constants for the speed and gap. Gap is set to 150. Um, this is the gap. This is always constant, and it is always 150. And we are having two rectangles for the lower wall and upper wall. So these two rectangles. And by the way, these are the rectangles that are used for checking collision in the word class. These rectangles. So on initialization of the wall class, or every time a wall object is created, it sets the main color to that is the color of the wall to brown, and a random number between 1 to 5 is chosen. That is achieved with this random function. So depending upon this random number, either 1 or 2 or 3 or 4 or 5, depending upon this random number, the upper wall height is determined with this switch class. So it's either 100, 200, 300, 400 or 500. So this upper wall height is determined randomly. And depending upon the upper wall height, we can easily calculate the lower wall height. So we are doing that by subtracting the overall height. That is, we are subtracting the overall height from the overall height. We are subtracting the wall height and then the gap. So if we are subtracting the upper wall height and gap from the overall height, we will be getting the lower wall height. So that is how we are determining the lower wall height here. And x is set to game window dot width. This means it always the wall should be starting from the right side, right? So the x is every time when this class is called or this object is created, the x is set to game window dot width, so that it always starts from the right corner. And we have dy set to 0, and I mean ui set to 0. Up ui is nothing but this one. Ui is always 0. So the upper world should always start from 0. And we are setting the lower walls y. Game window dot height minus lower wall height. So game window dot height minus lower wall height will give us this position. And we are setting the y position of the lower wall. And wall width is also constant. It's always going to be 50. And we are creating two different points for the wall movement. From point and to point. From point is game window dot width, and to point is minus game window dot width. That is from this end to this end. From right to left. The wall should always move from right to left. So this is the from point and to point, and using the vector to 2D, we are creating the direction, and using this velocity, we are creating the uh, movement, the direction, and we are setting the speed. And these two rectangles are the rectangles for the wall, upper wall and lower wall. After initializing the class, the next method is draw wall. In drawal method, we are just drawing the upper and lower wall by filling the triangle and giving x and y position and wall width and height and everything. So this is the method to draw the both the walls. And this update method is used to update the x position according to this velocity. According to this velocity, uh, the actual value of the x is changed, and this x is updated to the rectangles x and upper and lower rectangles x. And finally, we have a boolean is off screen class to check if the wall is still on the screen or is it outside the screen. And yeah, that's pretty much about the wall class. Finally, the scorecard class. We have X and Y for displaying the for setting the score for setting the score, and we are having the score variable for storing the score of the player, and we have the file path here for for the high score text file. Initially, I'm setting the score to 0, and I'm setting the file path location in the initializer. And the draw method in here is used to draw the score. That is, it's actually converting this int variable to string, and then it draws this score onto the screen in the x and y location that is given here. And send score method is used to send the current value of the score. Uh, and get high score, we have another method called get high score. This get high score method is responsible for getting the highest value from this text file. As I said earlier, every time when the player quits the game, or when the game over function is called, this text file is return of the current score. So from this text file, this function actually gets the highest value. That is done by creating a list called scores first, and if the file path actually exists, a new basically what happens here is the file is first read with this line, and the first the first loop in this first while loop, each and every line of the text file, that is each and every line of this text file, is added to lines list, that is to this list. But this line itself is a string, so we'll be having a list of string variables in this line list. To convert it to um, integer for calculating for identifying the maximum, we are running another for each loop here. For each line and line list, I'm converting each and every line value to an integer and storing it in scores list. So after doing that, I'm creating a new variable called max score, and storing the maximum value from this scores list. That is nothing but the maximum value from the file itself, and returning the max score out. If the file is not present, or if the file is empty, it's going to return 0. So that is about the scorecard class. Now we only have this Flappy Bird class. This Flappy Bird class is the coordinating class. This knows all these classes: bird, wall, and scorecard. And this using this, we are actually running the game. We are initializing the variable for game, for bird, window, and scorecard, homepage. For all these classes, we are initializing the variables here, and we are also having walls list and remove walls list. So here in wall, we were just this is just a blueprint to create one of the wall, that is with the wall class, we can only create one of this wall, but we want multiple walls created regularly at certain distance for the game to proceed. So for that to happen, we are storing each of the walls in this walls list, and once when the wall goes out of the window, if the wall goes out of the window, it is added to remove walls list, and the wall is deleted. So that is why these two list variables are initialized here. And we have quit wall space. So walls, we have a constant called wall space. Wall space is set to 300. So this is the reason why the space between walls is always constant. Yeah, in initializer, we are just initializing all these. We are just creating objects for all these variables and initializing the class. And next, we have the handle input method. In this handle input method, we are asking the bird class to handle input. That is, we are calling this function. So it checks for checks if we are pressing space bar. If we are pressing space bar, it is going to make the bird move upwards. Or if we are not pressing the space bar, it's basically going to make the bird move downwards. And then we are having this draw method from this class, and then we are checking if the bird is staying on the window, again from the bird class. So now let me show you what is actually inside this draw method. So we are setting the background here, and we are drawing the bird, and we are calling update. So before going on to this, let me tell you what this update function actually does. So in this update function, we are actually checking if it is the correct time to add new walls. So the wall should not be added every time when this update method is called. If that is the case, then the wall will be very nearer to each other, and the whole purpose of the game is going to be destroyed. So for that to not happen, we are having this game window dot width minus wall dot last. That is, we are checking the last wall exposition of the last wall, and if it is greater than wall space. So if the exposition of the last wall, for example, let us consider this is the last wall here, and if this wall's exposition is greater than the gap, that is, I mean, is greater than this wall space, and if this if this last wall position is lesser than wall space plus 5. I'm giving this one because wall space plus 5, it should be lesser than wall space 5, because once this wall crosses this 300 mark, it's always going to be greater than 300. So after this wall crosses 300, it's going to create walls consecutively near to the other walls, and then it's just not going to work. For that to not happen, it should always be like the wall push, the exposition should be greater than the wall space, and it should be lesser than 5 units. It should not be exactly 5 units. We can actually set it to like somewhere like 6 or 7, anything that we wish. So that is the reason behind this if statement. So if this condition is satisfied, a new wall is going to get added to this walls list. And the next thing we are doing here is for each wall and walls, we are calling the update method from the wall class, and then we are setting the score. That is, we are checking if the x position of the bird is exactly equal to the x position of the wall. So the bird's x position is should be equal to the wall's x position. That is, if the if so, this is the x position of the bird now. When the wall moves here and the wall's x position matches exactly with the bird's x position, the player's score is going to get added. And finally, we are checking collision. So we are creating a new wall from this method. This is just returning a new object every time. And for checking collisions, we are uh, running a for each loop here. And if the bird collides with the wall, the game over function is called. And here is where we are adding the wall to remove all list. So if the wall goes beyond the screen, it's going to add that particular wall to this removal screen. I mean, removals list. And in the next step, if there is something present in the removals list, it is going to just remove everything from the walls. And then again, it's going to clear the removals list so that it can add new ones. Okay, so all these methods are run before drawing the wall. So after this, only by this update class, the other classes are called, and after this is run, the walls in the walls list are drawn, and then the player score is drawn onto the screen, and the game is game window is refreshed. This this handle input is the one that is called here. So if the game is running, the handle input method from the Flappy Bird class is called, and the game continues until the player either quits the game, or if the bird collides with the wall, or if the bird falls to the ground. So if either one of the three I stated happens, it's not going to quit the game. It's just going to go to the home page, creating new home page and new game, and then it's going to do this. It's going to go into this loop to um, to the home page to start the game again. and only when the user presses escape key, it's going to quit and the game is going to get over. And yeah, this is the overall picture of how my Flappy Bird game is designed and executed. I think I've covered everything. That's it. Thanks for watching. Bye.